What if everything you have ever touched, every star you have ever seen, every memory you believe is yours, is not base reality at all? What if the universe is not happening but running, not created by gods, not born from chaos, but computed? And the unsettling thought is this: if it were true, would anything about your life actually feel different? We know with remarkable confidence that the universe obeys rules, not loose suggestions or approximate patterns, but strict mathematical laws that apply everywhere, every time, without exception. Light moves at a fixed maximum speed, no matter who measures it or where. Space and time are not passive backdrops, but elastic structures that bend and stretch according to precise equations. At the smallest scales, particles refuse to behave like solid objects at all. They exist as possibilities, not things, until an interaction forces a result. Reality itself seems reluctant to commit. When physics looks deeper, the familiar world begins to dissolve. Matter breaks down into energy, energy into fields, fields into mathematical relationships. Atoms, once imagined as tiny solid spheres, are now known to be almost entirely empty space. Particles behave less like dots and more like waves of probability, spread across space, defined by likelihood rather than certainty. Even the vacuum is not empty, but restless alive with fluctuations governed by invisible rules. At its most fundamental level, reality arrives in discrete units, packets of energy, smallest measurable lengths of space, smallest ticks of time. Like pixels on a screen, existence appears quantized, as though there is a resolution limit built into the universe itself. And through all of this, mathematics does not merely describe what we see, it predicts it, often before observation confirms it. Equations written on paper somehow anticipate the behavior of stars, particles, and entire galaxies. The unsettling implication is this: the universe does not simply contain mathematics. In a profound sense, it behaves like mathematics, structure first, substance second, as if reality is not made of things but of rules that things temporarily follow. And yet, not everything sits comfortably within this elegant framework. There are features of the universe that feel less like natural inevitabilities and more like unresolved questions hiding in plain sight. One of the most unsettling is how perfectly the universe seems tuned for observation. The fundamental constants of nature, the strengths of forces, the masses of particles, the rate of cosmic expansion occupy an extraordinarily narrow range. Shift them by even a small amount, and complexity collapses. Stars never ignite. Chemistry never stabilizes. Galaxies never form. In such universes, there are no observers left to ask why. Then there is the strange role of measurement itself. At the quantum level, particles do not exist as definite objects until something interacts with them. Until then, they remain suspended as probabilities, as if reality hesitates. Outcomes appear only when observation or interaction demands them. It is difficult to escape the impression that the universe is not fully rendered until it is queried, that existence somehow waits for confirmation before settling into form. Space and time add another layer of discomfort. When examined closely enough, they no longer appear smooth and continuous. Instead, they seem granular, built from smallest possible units, one shortest length, one smallest interval of time. Beyond these limits, the idea of smaller loses meaning. Reality itself appears to have a resolution, a minimum scale beyond which detail cannot exist. But why would a fundamental universe need such a limit at all? And perhaps, most troubling of all, is the universe's computational elegance. The laws governing it are astonishingly simple. The behaviors they generate are endlessly complex. From a handful of equations emerge stars, life, and conscious minds. This is not how randomness usually behaves. It is how systems behave when simple rules iterate over vast scales like a program, running patiently, producing richness from restraint. The first hypothesis is also the most widely discussed, not because it is comforting, but because it follows a cold and unsettling logic. If advanced intelligent civilizations tend to survive long enough to develop immense computational power, and if they use that power to create simulated realities, even for research, curiosity, or entertainment, then the numbers quickly become overwhelming. One original reality could give rise to millions or billions of simulated ones. In that scenario, simulated worlds would vastly outnumber the base reality that produced them. From a purely statistical perspective, this leads to a disturbing conclusion. Any conscious observer asking, "Where am I?" would be far more likely to exist inside a simulation than outside of it. Not because someone singled them out, not because of destiny or design, but because probability follows abundance. Numbers do not care about meaning, they simply accumulate. In this view, the universe is not fake, broken, or illusory. It is instanced a running environment governed by consistent rules, because consistency is computationally efficient. Physics becomes the engine that keeps the system stable. The constants of nature become adjustable parameters, set once and allowed to run. Complexity emerges not from constant intervention, but from iteration over immense spans of time. Within such a system, conscious beings are not scripted characters. They are emergent processes, patterns that arise naturally when information becomes sufficiently complex. And perhaps the most unsettling aspect of this idea is that it requires no malice, no intention, and no ongoing attention from any creator. The simulation does not have to care about us at all. It may simply be running. Another possibility is quieter, and in some ways, more profound. Perhaps the universe is not a simulation running inside a larger external reality, but a computational structure by its very nature. In this view, information is not something the universe contains. It is what the universe is made of. Matter becomes secondary. Space, time, energy, and particles are no longer fundamental ingredients, but emergent features patterns arising from deeper informational rules. From this perspective, reality behaves like computation, because reality is computation. Events follow rules, states update, outcomes emerge from prior conditions with logical consistency. There is no need for an external simulator, no distant intelligence monitoring a cosmic server room, no hidden machinery beyond the universe itself. The structure is abstract, self-contained, and sufficient. Existence unfolds as a process of logical evolution, step by step, moment by moment, governed by constraints that do not require intention. This idea resonates with modern physics, where equations often seem more real than the objects they describe. Particles appear as solutions to mathematical relationships. Forces emerge from symmetries. Even the fabric of spacetime may be a consequence of information being processed at a fundamental level. The universe does not compute for something else. It computes because that is the only way it can exist. Importantly, this view does not drain life of meaning. It does not reduce human experience to emptiness or illusion. Instead, it shifts where meaning lives. Meaning is not embedded in the system itself, waiting to be discovered. It is something conscious beings create through thought, connection, and choice inside a universe that provides structure but not purpose. A third idea turns the question inward, away from servers and equations, and toward the one element of the universe we experience directly. What if consciousness itself is the key? Not a late-stage byproduct of physical processes, but the very means by which reality becomes accessible at all. In this view, the universe exists as raw potential, vast, abstract, and largely unformed until it is filtered through awareness. Consciousness acts like an interface. It does not reveal the underlying machinery of existence any more than a computer desktop reveals the circuitry beneath the screen. Instead, it selects, organizes, and simplifies. Just as icons replace raw code to make a system usable, perception may translate a deeper reality into shapes, colors, objects, and moments that a biological mind can navigate. What we experience is not the universe as it truly is, but the version required for interaction. This perspective helps explain why reality feels stable, continuous, and solid, even if its foundations are anything but. The world appears reliable not because it is fundamentally made of solid things, but because an interface must be consistent to function. A usable reality prioritizes coherence over completeness. It hides complexity in order to allow decision, memory, and survival. Seen this way, the universe is not deceiving us, nor staging an illusion. It is doing something more subtle. It is simplifying itself so that conscious minds can exist within it at all. Reality becomes less a finished object and more a negotiated experience, shaped as much by the observer as by the structure being observed. This is the point where the question stops being scientific in the familiar sense and becomes deeply philosophical. A truly perfect simulation would be designed to hide itself. Any observation we make, any anomaly we detect, could always be explained away as a feature of the system, rather than evidence of something beyond it. In such a framework, proof becomes elusive by definition. The universe could always answer our questions in a way that keeps its deeper nature concealed. Even so, scientists and theorists have suggested possible paths forward. One approach is to search for limits to complexity in nature boundaries, beyond which reality refuses to compute further detail. Another is to look for mathematical shortcuts embedded in physical laws, signs that the universe favors efficiency over richness, as engineered systems often do. Researchers also examine whether spacetime behaves like a compressed structure at extreme scales, where information density reaches a maximum and further detail simply cannot exist. Others propose searching for computational artifacts, unexpected symmetries that serve no physical purpose, hard limits on information storage, or subtle inconsistencies that appear only at the very edge of what physics allows. These would not be errors in the human sense, but fingerprints of an underlying computational structure pushing against its own constraints. And then there is consciousness. Some argue it may be the most revealing clue of all. If awareness cannot be fully reduced to physical interactions, if subjective experience resists complete explanation, then it may point towards something deeper than material reality alone. But here is the uncomfortable truth that shadows every attempt. Definitive proof may never arrive. The answer, if it exists, may always remain just beyond the reach of measurement. If we are living in a simulation, the stars remain just as distant as they have always been. Their light still takes years, centuries, or millennia to reach us. Love still carries weight, and loss still leaves a mark. Time continues its quiet, irreversible movement forward, indifferent to our theories about its origin. Morning still arrives, memory still fades, and the choices you make, small or large, continue to shape the course of your life in ways that cannot be undone. Your thoughts still matter, not in an abstract cosmic ledger, but in the immediate and human sense. They matter to you, to the people who share your days, and to the fragile web of relationships that give life its texture. A simulated universe would not erase responsibility, nor would it cancel consequence. Meaning would not vanish simply because the underlying structure turned out to be unfamiliar. Perhaps the deeper question has never been whether the universe is simulated at all. Perhaps it is whether meaning depends on origin. A song does not lose its beauty because it is recorded rather than performed live. A story does not become hollow because it is written in ink instead of spoken aloud. And a thought is not made less real because it emerges from neurons or even from code. The most profound realization may be this: whatever the universe truly is, your experience of it is immediate, vivid, and inescapably real. The wonder you feel, the fear you confront, the connections you form, none of these are diminished by the possibility of a deeper structure beneath them. Even if reality is simulated, the life you live within it is not. At Stellar Inquiry, we are not here to chase answers simply to close the case. We are drawn instead to questions that refuse to settle, questions that widen the universe rather than shrink it. The kind that make the night sky feel deeper, time feel more fragile, and our brief moment within it feel unexpectedly precious. We follow ideas not to strip away mystery, but to stand quietly at its edge, where certainty fades and curiosity remains. Because some questions are not meant to be solved like puzzles. They are meant to be carried thought by thought, generation by generation, shaping how we look at the stars and how we look at ourselves beneath them. In asking, we do not lose meaning, we refine it. Even if the universe is a simulation, the awe you feel while questioning it, the stillness, the wonder, the quiet humility of not knowing is undeniably real.